Hi guys, this is a video for chapter 8, lesson 5. So in this video, we're going to continue to take a look at our line graphs on a coordinate plane. And so I would definitely recommend taking down a few notes here. When we create a line graph, right, that's what we've done in the last few lessons, we can actually relate the y-axis, the amounts on the y-axis, to the amounts to the x-axis. And there's a direct relationship between your x and y. You got your input and your output. And when there's a consistent relationship, we can create a line and we have a linear equation, right? So a relationship on your graph that have a straight line graph, let's say that, are called linear relationships. Okay, so that's something that we already know is true. And a linear relationship has a constant rate of change. And so that's what we looked at in lesson 8.4. And then we looked at slopes, how we can also describe the rate of change really as a slope. And we looked at that in lessons 8.6. And so coming back to this one, we see that a linear relationship has a slope. It has a consistent slope that's consecutively going up, or a consistent rate of change. And so you can find the rate of change by basically looking at, remember, just to remind us that the rate of change is basically the difference of the y's over the differences of the x's. Okay, so y2 minus y1. So you're picking 2 points, finding the differences of the y's, and then finding the differences of the x's. And so what we're going to look at today is basically deciding if a linear relationship is proportional relationship. So a linear relationship is proportional if the ratios of y and x are always equal. So we'll talk about this. So that's saying if I have a graph and if I identified a few points here and I put the y over the x for each of these points. So I did it here, I did it for this point, I did it for this point, I did it for this point. If they're always equal, then this linear graph, this linear relationship is proportional. If when I set them up as a ratio and they're not equal every single time, then they're not proportional. So let's take a look at an example on your study guide. So basically, with this example, they've looked for the rate of change, which I don't feel like I need to talk too much about. So right here, they were just finding the rate of change. As the tomato plant grows, it's growing 2.5 inches per week. And so it's going up 2.5 inches every week it goes. So it goes 2.5 up over 1 as the week goes, 2.5 up, and then over 1 as it goes. So to determine if it's proportional, they are going to pick points and put the y over the x for points on the graph. So there's a point here. Maybe I use my purple pen here, but there's a 5 inches to 3 weeks. So that's a point here. There's 10 inches to 5 weeks, and there's 15 inches to 7 weeks. So turning these into ratios, it would be 5 over 3, 10 over 5, and then 15 over 7. And so what they've done there is they've created the ratios, 5 over 3, 10 over, is it 10 over 3? Should be 10 over 5. I think that's a typo, 10 over 5. And then 15 over 7. And when they simplified this out and wrote it as a decimal, it was not the same. So even if you look at simplifying it, you know that they're not equal already. So the ratios are not equal, so the linear relationship is not proportional. That's all you're determining. So looking here, it says find the constant rate of change for the linear function at the right and interpret its meaning. Then determine whether a proportional linear relationship exists between the two quantities. Explain your reasoning. So first we need to find the constant rate of change. In other words, we need to find the slope. So I'm going to pick these points. Remember we talked about picking points where you can identify what the numbers are on the x and y. If I picked it like in the middle of the box, I won't be able to tell, is it quite 1 pound, not quite 1 pound, and then what's the price, right? So I'm picking points where I can read the numbers really well. So to find the rate of change, I'm basically finding the slope. So I'm going to pick 2 points. Maybe I'll highlight them. I'll pick this point and this point. And you can pick any 2 points and you'll get the same slope. So this point is at 1, 2. Okay, and this point is at 3, 6. And so I'm going to subtract my y's. So 6 minus 2 over 3 minus 1. And when I subtract, I have 4 over 2. When I simplify, it's 2 over 1. So thinking about the rise is going up 2 maybe dollars, and then the run is going up per pound. So for the rice prices, if I were to describe, every pound is $2. So for every $2 I pay, I get another pound. And you can see that. So now what we're going to decide, so this is the first step. The second step is to decide if it's a proportional linear relationship. So we're going to have to check all these points here. And what we're going to do is we're going to put the y over the x. So I've got 2 over 1 as one of my points. I've got 4 over 2, 6 over 3, 8 over 4. Okay, are these all equal? Do they simplify to become the same fraction? So 2 over 1, this becomes 2 over 1, 2 over 1, 2 over 1. So yes, these are all equal. I'm going to make them all equal. And so I would say the ratios are equal. So it is, the linear relationship is proportional. Okay, so I suggest you write it out like a full sentence, but it's hard to write with my pen, so I'm just keeping it simple there. Okay, so the next thing we're going to take a look at is something called direct variation. So let's go back to our notes a little bit, clear this off. And direct variation, let's title this direct variation. This really just means a constant change, okay? So when the ratio of 2 variables, so the 2 variable quantities is constant, their relationship change is called the direct variation. So meaning if the ratio of the 2 variable quantities are consistent, so it's really saying there is a proportional relationship where the change of the y over the x is consistent, then we call it having a direct variation. A variation kind of means change, so a direct, straightforward change. So an equation that we use to show direct variation is by saying y equals k times x, okay? So the direct variation is a relationship where the ratio of y to x is constant, and so we call that direct relationship k. And so this k stands for the constant change. Okay, so if I were saying, going back to that last example with the rice, let's say it's going up $2 per $1. or per 1 pound, right? So the constant change is that it goes up $2 per 1 pound. So if I wanted to find out how much it would be, I would say, okay, the constant change is $2 per pound, and I want to buy, 5 pounds. That would be X, right? If we looked at our graph, X is your pounds. And maybe this, I'm losing you here, but we'll do a few examples. X is your pounds, the Y is your dollars. And so if we wanted to find how much, we would have to use that constant change, the direct variation, to calculate how much we would have to pay if we bought 5 pounds. So this is kind of like the constant rate in some way, okay? So let's go back to our example. And here we don't even have a graph anymore, but we have the X and the Y. So this, if this is an example where we know that there's a direct variation between the X and Y. So reading the question, it says, a scuba diver descends below the surface of the ocean. The pressure that they feel from the water varies directly with the depth. So this already tells us, okay, there's a direct relationship between X and Y. So to find the direct variation, really it's just Y over X, and that equals K. And so if we work this out and do, 8.9 over 20 equals K, we could find that would be 0.445, and they've done that here for us, okay? So if I had divided this, or if they did, they picked this point, 17.8 and 40, well, we know that the change, the X and Y are constantly have the same ratio, and so it's 0.445. And so now we can use our direct variation to predict future amounts. So we found K, and so in an equation we could say Y equals K times X. K is 0.445. So now if they said predict what the pressure will be at 28 feet, so we don't have 28 feet here, but we can use this direct variation to predict what the pressure, the water pressure, would be if the scuba diver went down 28 feet. And so we can plug 28 back into X and find out what the water pressure would be. And it would be 12.46 pounds per square inch of water, okay? So let's take a look at these word problems. The amount that Jared earns every week varies directly with the number of hours he works. Suppose last week he earned $75 for 6 hours. Write an equation that could be used to find out how much Jared earns per hour. Okay, so really what we're saying is, what's that constant rate? What's the rate there? So we could say the direct variation would be 75 over 6 hours. Let's simplify that. Maybe write it as a decimal. Uh-oh, don't know what's going on. There it is, okay. Okay, I was having some issues here, but I'm back. Okay, so we found out that it would be, when we simplify this, it would be $12.50 per hour, really is kind of that rate. Okay, and so now we want to predict, we're going to write it as an equation. So I'm going to say Y equals 12.5 times X. And now we're saying, well, how much would he earn if he worked 25 hours? So now we can multiply that by 25, write out our equation, and Y equals $312.5. That's how much he would earn if he worked 25 hours, okay? So hopefully this isn't as crazy as it sounds. There's some new words, but I think you've done something like this before. The cost of buying gas varies directly with the number of gallons purchased. So suppose Lena bought 12.2 gallons of gas for $35.99. So usually we always calculate money to item, right? So that we know how much money is per 1 gallon or something like that, right? So we're going to say $35.99 over 12.2 and plug that in. So it's like $2.95 per gallon. Okay, so that's kind of like the unit rate, right? And so now we want to find out how much would it cost if we bought 9.5 gallons. So our equation is going to be y equals 2.95 times x. Replace x with 9.5. And it's about $82.67. So okay, and it would be good if you could write out the equation right and plug in what it would be for x and then show your work. I'm limited on room here. Hopefully you're doing this on a piece of paper. Okay, geometry. The circumference of a circle is in direct variation with the diameter of the circle. Quan drew a circle with a circumference of 47.1 inches and a diameter of 15 inches. So there's a direct variation of circumference to diameter. And once I put this number down, I think you'll be familiar with it. 47.1 divided by 15, 3.14. Cool. What do we call this number? This is the number that we call pi, right? 3.14 is k, okay? So that means y equals 3.14 times x. And now if we want to find the circumference of a circle with a 12-inch diameter, then we can just multiply by 12 here. So its diameter times pi is really how you find the circumference. So plug in our equation, 3.14 times 12, and y equals 37.68 inches as the circumference. And there it is. Okay, and that's it. So hopefully that makes sense. You can ask me any questions, email me if you're confused.